Hi, what is exponential or compound growth? Well, let's use an example. Let's say you have £100 today and you put it in the bank, and after a year they'll add 5% interest. How much would you have after a year? Well, I'd have the amount I started with, which is £100, and now we need to add on the interest. And we need to do £100 times 5%. Or another way to write that would be £100 plus £100 times 0.05. 0.05 is the same as 5%. So we would have £100 plus £5 to give us a total of £105 after a year. Now, if the bank had 5% interest after another year, after 2 years, how much would you have? Well, the interest wouldn't be £5 because we would start with £105. So we'd have 105 plus 105 times 5%, or 105 times 0.05. And we would have the amount we started with, 105, plus a new amount. And we can use our calculator. 105 times 0.5 is £5.25. And we would have a total of £110.25. So notice in the second year the interest is £5.25, which is more than the interest in the first year of £5. How much would you have after 3 years, or after 10 years? Well, let's do it for 3. We would start with £110.25, and we would add 5% of that. We would multiply £110.25 times 0.05 to give the amount we started with, plus the interest. Let's use our calculator again. £110.25 times 0.05, and we have £5.51. To give us a total of £115.76. Now, I don't want to do this another 7 times to find out how much I'd have after 10 years. So let's see if we can do it another way. Let's see if we can write a formula for calculating the compound interest. We go back to question 1. We started with £100 and we added 100 times 0.05. Well, we can rewrite this to say 100 times 1, well, let's put some brackets around it, and 100 times 0.05. So it's £100 plus £5. Well, we're multiplying 100 by 1, and we're also multiplying it by 0.05. So another way to write this would be £100 times 1 plus 0.05, and 1 plus 0.05 is 1.05. So we can do £100 times 1.05, and just to double check with our calculator, 100 times 1.05 is 105, and we get the same answer. So notice that we multiplied 100 by 1.05. I wonder what would happen if we multiplied 100 times 1.05 times 1.05. What would we get? Well, we can use our calculator again. And we get £110.25. Which is the answer we got before. So starting with £100 and multiplying by our multiplier, and our multiplier is 1.05, if we do it once, we get the amount after 1 year. If we do it twice, we get the amount after 2 years. So let's do it again for 3. £100 times 1.05. Then we do it 3 times. What would we get with our calculator? It's once, twice, 3 times, £115.76. Which is the answer we started with. So after 3 years, we multiply the original amount by 1.05 3 times. Now, I don't want to do this for 10 years. So I know that, for example, x times x is x squared. And 1.05 times 1.05 is 1.05 squared. So on our calculator, we should be able to do 1.05 cubed for 3 years and multiply that by 100. And let's see what we get. 1.05 to the power of 3, or cubed, is 1.157625. And if we multiply that by 100, we get £115.76. So we could rewrite this as £100 times 1.05, and I'm going to do a little cubed sign here. £100 times 1.05 cubed gives us the same answer. So after 10 years, it'll be 100 times 1.05 to the power of 10. And using our calculator, 1.05 to the power of 10 gives us 1.62889 if we multiply that by £100, £162.89. So what's the formula? Well, the formula is the amount I started with. So I can say that the value is the amount I started with times 1.05 to the power of x. And the 05 part of 1.05 is the rate of interest, which is 5%. So we can write this again. The value is the amount. Now 1.05 is 1 plus 0.05. And 0.05, or 5%, is the rate of interest. So we could do R for the rate of interest, which would be 5, and we could divide it by 100 to give 0.05, and then do the power of x. So that's our formula. The value equals the amount times 1 plus r divided by 100 to the power of x. And we can plot this as a graph. And on the x-axis, we have the number of years from 1 going all the way up to 15. And on the y-axis, we have the amount. And after year 1, we have 1.05 times the amount we started with. After year 2, we have 1.1025, or if we multiply that by 100, £110.25, and so on. And after year 3, we would have £115.76. And I can see from this graph that after roughly 14 years, we have twice the amount we started with. Now, if we carried on drawing this graph, we would have this. And we can see that it's a curve and not a straight line. And the slope, or the gradient, is getting steeper and steeper as we go up. And that's what we mean by compound or exponential growth. Thank you for watching.